Are you able to hear me? Okay, right. So I'm seeing some of you are online, and I'm seeing names getting added over here. Poojan is there, Chintan is there, Dhruv Parsana, Alap is there. Right. So once again, please confirm to me whether you are able to hear my voice clearly or not. Are you able to hear me clearly? That's okay if people are not interested, but I just want to confirm whether. Okay, so that's great. I think you are able to hear me and crystal clear. Great, super. So let's start off. I think there's no point in waiting uh, too much. And let's start off. And what we'll do is I'll just pick up a question from the assignment which I had given to you yesterday, and and some of the questions we had discussed today. And for example, horizontal projection of a projectile. And I'll start off with question number 4. Uh, an aircraft is flying at a height of 3,500 meter above the ground. I hope all of you have the question paper, the assignment in front of you, right? And I'm doing question number 4 in the first type A horizontal projection of a projectile. Question number 4: an aircraft is flying at a height of 3,500 meter above the ground. If the angle subtended at a ground observation point by the aircraft positions 10 seconds apart is 30 degrees while passing over his head, what is the speed of the aircraft? So what I'll do is I'll draw a diagram. In the meantime, you can read the question again. So what has been given, if this is the ground and this is, let's say, the aircraft flying in this direction, and it is given that it is flying at a height of 3,500 meter. So this is the distance from the ground, 3,500 meter. And when it is over here, it subtends at an angle of 30 degree. So when it is over here and when it is over here, the time that is required to move this is, say, 10 seconds. And these two positions subtend an angle of 30 degree. So this angle is 30 degree. This angle is 30 degree. And this is the position 1 of the airplane, and it moves in this direction. After 10 seconds, it is over here. The angle subtended over is 30 degree. What else is given to us? 3,500 meter height is given to us. What is the speed of the aircraft? So we have to find out the speed of the aircraft. Now what I can do is I can draw a line like this vertically over here, and obviously this angle is going to be 15 degree. So if I call this O, A, B and C, then if I look at triangle OAB, then this particular distance OB is 3,500 meter from here to here. This is 500 meter, and the time taken to move from here to here is, if this is 5 seconds, the time taken to move from here is 5 seconds. So time to move from A to B equal to 5 seconds. Now this angle is 15 degree and we know the height. So if I take tan of 15 degree, that will be AB opposite side upon this adjacent side, because OA is the hypotenuse. So this will be OB. So if I find out tan 15 degree, I know the value of tan 15 degree from the calculator. AB, OB is 3500 meter, so this will be AB upon 3500 meter. So I get AB is equal to 3500 into tan 15 degree, and if I do this calculation, AB will turn out to be 937.8 meter. You can do this calculation and you get this. And now I can find out the velocity. Velocity is equal to distance upon time. The distance AB is 937.8, and the time taken to move from here to here is 5 seconds. So 937.8 divided by 5, and that will give me a value of 187.5 meters per second. So this is how you are able to get the speed of 187.5 meters per second. I hope all of you are still with me, right? And I just want to once again, before I move to the next question, I want to confirm once again that just put in a thumbs up sign or a yes, so that I know that you have heard me through this question and you're able to see the screen. Can you just give me a thumbs up sign, or just write yes or Y or whatever, so I know you are with me. And Dhruv Prasanna has written yes. Okay, great. Okay, Kunj has joined us. Yes, and we have some more joining in. Okay, so I got a yes from Alap also once again. So let's move further now. I have done attempted question number 5, and I'll now take a new slide, and I'm saving this slide under the name question 5, so I can send it to you later on. And let's now move to the next question. So let's move to the angular projection of a projectile part, and let us say we want to look at one more question. Let's say we look at question number 10. Right? Two particles are projected uh, from the ground simultaneously with a speed of 30 meters per second and 20 meters per second at angle of 60 degree and 30 degree with the horizontal in the same direction. Find the maximum distance between them on the ground when they strike. So we have a situation like this over here. So if I say this is the ground, and two particles are projected from the ground, right? So one falls like this probably, and the other one probably falls like this. We don't know. One is falling over here, and what is given to us? We have been given that they're projected speeds of 30 meters and 20 meters per second for 60 and this. So if this is 30 meters per second, the angle is 60 degree, and this is projected at 20 meters per second, and this angle is 30 degree with the horizontal the same direction. Find the maximum distance between them on the ground when they strike. So we have to find out this particular distance. Now this is a case of projectile motion, and I can use the formula R is equal to U square sine 2 theta by G. Right? I just want to stress this point. This is a case where the object starts from the ground and reaches the ground. So I can use the equations that we have derived for projectile motion. And this is the equation that we have for range. R is equal to U square sine 2 theta by G. So if I take it for R1, this is the first case. Then U is 30. Let me write over here 30 meters per second is U, and the angle is 60 degree, and for the other 20 meters per second, and the angle is 30 degree. So for the first case 30 meters per second, so I'll get 30 into sine of 2 theta. Sine of 2 theta would be sine of 120 degree divided by 10. because we have been given the value of g as 10 in this question. So if I solve this, I'll get, this is 30 into 30 into sine 120 upon 10. So sine, if I solve this, right, I've actually solved it already. You'll get a value of 45 by square root of 3 meter. Sine, just for your information, sine 120, what will be sine 120? Sine 120 will be sine 180 minus 60. In the second quadrant, sine is positive, so sine 60, and sine 60 is root 3 by 2. So for this, I'll get root 3 by 2, and if I solve it further, I'll get 45 by root 3 meter. Okay, as far as R2 is concerned, again I'll use the same formula, u square sine 2 theta. Velocity is 20, so 20 into 20, sine of 2 theta, so sine of 60 divided by 10. And if I solve this, what do I get? 10 2 is sine 60 is root 3 by 2, so 2 into 20 into root 3 by 2, so 2 gone, so I get 20 by root 3. So this is R1 and this is R2, and therefore the difference between them, R1 minus R2, will be R1 minus R2 will be equal to 45 square root of 3 minus 20 square root of 3, and that will be equal to 25 square root of 3 meter, which is the given answer. So the first stone, which is at 60 degree, goes further. Actually, it goes 45 by root 3 meter. The second stone goes at 25 by 3 meter, and this is what the difference we get. So I have solved the second question. I hope this is making sense to you and it is helping you. If you have any suggestions while I'm solving this, if I'm going fast, slow, or anything, please let me know. Are you okay with this? Darshil has joined us. Manav is there. Okay, so we have a few more joining in. Are we okay with this? We've done the second question. Pujan Biram Gama is asking me to wait. Right, okay. Yes, Pujan, any specific reason you want me to wait? Kunj Dilesha is saying okay, everything okay. Super, so great. Now let me quickly move on to the next question. So again, I'm saving this file so I can share it with you later. And this I'm going to call question number 10 and save it. Okay, open a new file. Right, so we have this, we solved question number 10. Let's move on to one more question, and let me choose one question. Question number 13 we already did in the class, I think, so I don't want to do that. Let us do question number 12 because it has got the orthogonal unit vectors in it. So let me do question number 12. What does it say? A projectile is given an initial velocity of I plus 2j. So u is equal to I plus 2j. Of course, I should put this hats over here, I plus 2j. What else is given to us? Where I is a unit vector along the horizontal and j is a unit vector vertically upwards. Find the Cartesian equation of its path, and g is to be taken as 10 meters per second square. Now, if this is the equation, what we need to understand is that u is equal to ux I plus uyj. This is the standard form of a orthogonally unit vector form. U is equal to uxi plus uyj. You will remember we discussing this axi plus ayj. Similarly, u is equal to uxi plus uyj. So if I compare this, I get ux is equal to 1 because you don't have any number over here. That means we have 1. So ux is 1, which is equal to u cos theta, because ux is equal to u of cos theta. This is uy. So uy I now know is equal to 2 is equal to u sine theta. So from this I can find out the value of u. U is equal to square root of ux square plus uy square, and that will give me 1 square plus 2 square, and that will be square root of 5. So the magnitude of this vector, is square root of 5. That means this velocity is square root of 5. And if I want to find out tan theta, I can write down u sine theta upon u cos theta. I know the value of u sine theta. U sine theta is 2 and u cos theta is 1. So therefore I'll write down tan theta is equal to 2. Okay, so I got these values now, and you must be wondering as to why I have done all this. Now we have been asked, the question over here is find the Cartesian equation of its path. Now if you remember, we had done this derivation. The equation for projectile motion is y is equal to tan theta x minus 1 upon 2 g by u square cos square theta x square. This is the general equation for projectile motion. So now I can put these values over here and get that Cartesian equation. So y equal to tan theta we have found out 2. So I can write down 2x minus half. G I can take as 10. This is meter minus square. So G is 10. And u cos theta, this is u cos theta whole square. Now what is the value of u cos theta? Is 1. So this will be 1 square. So it will be 1 into x square. And what will this give me? Is equal to 2x. 2 ones are 2 5s are. So 2x minus 5x square. This is the equation that we get. And you can see in the answer, this is the equation that we get. So basically we have to use this equation to get that equation and find the value of tan theta and u cos theta and plug those values over here. So this is question number 12. Okay, sir, can you solve 21 question? Okay, you don't, not able to understand question number 21. Okay, all right, we can move to question number 21. Okay, a body is projected. So Pujan is saying go little slow. Sorry, sir, you can solve 21 and it's a 21st. Okay, okay. So I'll go a little slow as somebody has pointed out, and we'll do question number 21. Okay, so let me look at what is question number 21. Let me do this. Let me save this. Save, and this was question number 12. I'm showing question number save 12, and now I'll do question number 20. A body is projected with velocity u1 from point A as shown in the figure, and at the same time another body is projected vertically upwards with the velocity u2 from the point B. What should be the values of u1 upon u2 for both the bodies to collide? Okay, so let's look at this question. I'll draw the diagram again over here for my reference. So this is the situation over here, and this is u1, and this angle is 60 degree, and from here a body is projected upward with velocity u2, and this is location B, and then this object goes over here and they collide over here. If that is the case, if this object starts from here, reaches over here, this object reaches over here, they collide, then what is the ratio of u1 by u2? That is the question. Okay, one thing that I'm sure you have realized that if this collision has to happen, the vertical distance that this object has traveled and the vertical distance that this has traveled has to be same. Both are at the same h. This h, this particular h is same for both of them. Also, the time for this object to go from here to here and the time for this object to go from here to here is also same. So both h and t have to be same. Only then we can have this situation. Instead of h, I will use probably y, because the vertical direction distance is taken as y. Okay, let us find out y for this particular object. Let's call this as object A and this as B. So for A, I'll first find out y. Now I can use the equation y is equal to ut plus half at square. What is u? U will be u sine 60, right? I'm sure now you understand this, that this has two components, u cos 60 and u sine 60, and u sine 60 takes it up. So the initial velocity that I will take will be u1 sine 60 into time t minus half gt square. Okay, so this will give me sine 60 is root 3 by 2, so root 3 u1 by 2 t minus half gt square. Okay. Similarly, for object B, y2. Now this is going straight up. Again, I'll use the equation ut plus half at square is equal to. In this case, u is vertical, so I will have u2 t minus half gt square. So I have got this vertical displacement from this. Now y1 equal to y2, because both this and this object have covered the same vertical distance. So y1 equal to y2. So I can take this equal to this. So I will write down root 3 by 2 u1t minus half gt square is equal to ut minus half gt square. Please note another thing. T for this and t for this, they are also same. They are not different because they have to reach here and collide, therefore same time. So t is also same. Okay, now if I look at this equation, this is minus half gt square minus half gt square gets cancelled out. So I can just check this out, and now I'm running short of space, but okay, I'll use this space. So I'll get root 3 by 2 u1t is equal to u2t. T is same, goes over here. So u1 upon u2. u1 upon u2 is equal to 2 by root 3. And I think that's what the answer is. Yes, 2 by root 3. So this is how we get these two values. And now I'm sure you have realized that it's a simple question. Basically, we have to equate the vertical height for those objects, and you automatically get that. Yes, so I have done the 21st question as you had asked. Are you there with me, all of you? Because my screen shows watching 0, so I'm wondering if any people of any of you is watching. Sir, how do we know that the time will be same for both? If I go back to the diagram, let me go back to the diagram. This one. See, it is said that this object starts from here and this object starts from here. And if both of them are starting at the same time, and if they're colliding over here, that means the time that this object takes to reach over here, if suppose that is t, this object also should take time t, otherwise they will not collide. Supposing this one takes time t plus 2 seconds to reach over here, that means when this reaches over here, this object will not have reached over there. They have to take the same time to reach this height. I hope that makes sense. Supposing two objects are starting, and this is the point where they are beating it. They go and hit over here. The time taken by this object to move from here and the time taken by this object to move has to be same. Otherwise, they will not collide. Therefore, we say that the time required by both objects has to be same. Both h and time have to be same. Otherwise, when this reaches this height, this object would not have reached that height. It would be either here or it might have already passed by this. same distance, I won't say same distance, so same time, they are colliding, so same distance, and if they are colliding, they're starting together, therefore same time. If they are not starting together, then they would not have same time. But since they're starting together and coming to the same point together, therefore time also is same. Good. Okay, so I've done 21st. I've done question number 21. Okay, let's do one more question. Let's do question number 19. Uh, a particle is projected with a velocity u so that its horizontal range is twice the greatest height attained. Find the horizontal range of it. So I'm now doing question number 19, if that's okay with all of you. Right, I'm just picking up numericals at random. There's no specific pattern I'm following. And so, okay, let me say this is question number 77. So, question 27. Okay, new. And, right, so let me look at question number 19. It says that a projectile is projected with a velocity u so that the is horizontal range is twice the greatest height, so 2 times h. Find the horizontal range. We have to find out r. Now we know the equations for h. H is equal to u square sine square theta by 2g, and the equation for r is equal to u square sine 2 theta by g. And you should keep these formulas in mind quickly so that we are able to solve questions quickly. This is the value, this is the equation for h, this is the equation for r, and it has been given r is equal to 2h. So I will write down u square sine 2 theta upon g. This is equal to 2 times this. 2 times this means 2, and 2 will get cancelled out. So I will get u square, or let me write down u square sine square theta by 2g. 2 times 2, 2 will get cancelled out. What else is getting cancelled out over here in this case? Second, similarly, this u square and this u square will get cancelled out. This u square, g and g will get cancelled out. So I'll be left with sine 2 theta is equal to sine square theta. That means 2 sine theta cos theta is equal to sine theta into sine square theta. Because sine 2 theta is 2 sine theta cos theta, and sine square theta I'll write as sine theta into sine. So what happens? Sine theta gets cancelled out. Sine theta gets cancelled out. So 2 cos theta equal to sine theta. Therefore, sine theta upon cos theta is equal to 2. Sine theta upon cos theta equal to 2. Therefore, tan theta equal to 2. And if I use your calculator, I'll get from this tan theta as 63.4 degree if I want to find out. And then I can find out the value of r, because r is u square sine 2 theta by g. And then I can write down u square into sine of 2 theta, 63.4, so 126.4 by g, sine 126 by 4. Again, I'll use the calculator to get this particular value, and what I get in my calculation, I get is 0.8 u square by g, and this is the right answer. In the book, the answer is given 4 upon 5 u square by g, which is same. 5 to the 10, 4 to the 8, 0.8. So 0.8 u square by g is the answer for question number 19. Okay, Kashish has joined. So can you show question 20 again? I want to write it down. What I'll do is I have saved the file of the solution of question number 21. I'll upload it on Edmodo, so you can take it from there. Right now, if I show it up, it will take a lot of time because it's a fairly long solution. So I'll upload it. Make it. Please remind me to do that. What I'll try to do today itself is upload all these solutions on Edmodo, so you can refer to them. Ask her, she will mail you the picture. Yeah, I'll do that. Chintan Kashish check 9.44. Okay. So I've done 19th question, and then 21st, then 23, 24, 25. These are all questions on circular motion, so we don't have to do them right now. And a typical problem, before I do typical problems, I want to rather spend more time on solving these simple questions. So if you are able to do questions from 21 onward, circular motion we want to 21 I have done, at 19 I have done. Okay, let's I want to do as many as possible so that you people have. Let's do question number 17. Okay, let me see what is, has anybody written anything? No. Okay, I'm moving to question number 17 now. So read question number 17. Okay, this I am saving. Question 19. Okay, question number 17. It says a bullet is fired from a rifle, attains a maximum height of 5 meters. So maximum height is 5 meter and crosses a range of 200 meters. Find the angle of projection. Theta is to be found out. It's relatively simple question. So I'll use the equation for h and r. I know that h is equal to u square sine square theta by 2g, and this is equal to 5, given h is 5. So the u square sine square theta 2g is 5. Okay. Similarly, r is given to us, and we know r is equal to u square sine 2 theta by g is equal to 200, given. So I have these two equations, and from this I can find out u sine theta and u cos theta. So what do I get from here? As what is the value of g given to me? It's not mentioned over here, so I'll take it as 9.8. So if I use this equation, I'll get u sine theta whole square equal to 2 into 9.8 into 5, and therefore u sine theta is equal to square root of 2 into 9.8 into 5, and this will give me a value of 7 into square root of 2 meters per second. So I got value of u sine theta now. Now this is u square sine 2 theta is 2 theta. So u square sine 2 theta is 2 sine theta cos theta by g is equal to 200. Now this 2 I'll write first, and this u square, so I have u into u. One u I will keep with sine theta, the other u I'll keep with u cos theta. So I can write this as u sine theta into u cos theta by g is equal to 200. Now in this value of 2 u sine theta, we have already found out is sine into square root of 2 into u cos theta is equal to 200 into 9.8. This g comes over here, and from this I can find out the value of u cos theta, and the u cos theta comes out to be 140 by square root of 2. This is the value that it comes out, and this would be approximately 140 by square root of, because square root of 2 is 1.41, so this would be approximately 100. Of course you can take the exact value by using the calculator, but you get nearly 100. And now I know u sine theta and I know u cos theta, so I can find out the value of this velocity, because u will be equal to square root of u cos square u cos theta whole square plus u sin theta whole square. So u sin theta is u cos theta is 100, so this will be 100 square plus square of this will be 49 into 2 98, and if you solve this you will get some value of u over here. Have I done that calculation? No, I have not done that calculation because it is not asked. So but you can find out u from here, and the question asked is theta. So now we know that tan theta is equal to u sin theta by u cos theta is equal to u sin theta is 7 by root 2, u cos theta is 100, so we can find out tan theta, tan inverse of 7 by root 2 by 100, and if you get this you will get 5.6 degree, and this is 5.6, whereas the answer given is 5 degree 43 5 degree 43 seconds, right? Please note that this is 5.6, so it would approximately be equal to 5 degree and 43 seconds or somewhere around that, but we are very close to the answer, and therefore we take this as the answer, 5.6 degree. So basically in this question what we do is we take h, value of h is given, value of r is given, we play around with these equations and then find out the value of theta. Okay, done in class, you said. Had we done this class? Sorry, if I've done this class, if I've repeated it, I'm sorry. I think for today is that okay, or you want me to do anything else? Darshil Makadi has written 8th question number 8. Question number 8 is what? Prove that a gunshot will shoot 3 times as high when its angle of elevation is 60 degree as when it is 30 degree, but cover the same horizontal range. Okay, question number 7. Kashish Dedwadi is saying 24th. Kashish, 24th question is on circular motion, so therefore, and since we have not done circular motion, I am not doing that. Okay. Somebody has asked question number 7, so it is done. Dhruv, it is not done. Okay, anyway, if I have done it again, not an issue. Okay, Darshil is asking for question number 8, so I'll do question number 8. Just give me a second. Hello, hello. Yeah. What we'll do is we'll do last question number eight, and then probably we will end up. I think we had a good trial session, and I had some technical issues initially, but then I think I have settled down, and probably we'll do question number eight and then wind up, right? And we'll call it a day for today. So I'm doing question number eight now, which is the last question, and just arranging my material. Okay, so this I'll say five. Say this is question 17. Okay, question number eight. I'm doing. Right. And what does the question say? The question says that just looking for the question says that prove that the maximum horizontal range h maximum horizontal range is 4 times the maximum height attained. So maximum horizontal range is r, that is 4 times the height attained by a projectile which is fired along the required oblique direction. So this is what has been asked to be proved. Now we know, please note this, here we will ask maximum horizontal range possible for any particular angle. So let us say we have this ground and an object is thrown, and this is the range r. Now, r we know is u square sine 2 theta by g. So if I take the same velocity u, then for the different angles I'll get different range, and from this I can prove that the maximum range r max I get when theta is equal to 45 degrees. We have done in this in the class, but once again I want to quickly repeat this. For the range to be maximum for a given velocity, sine 2 theta has to be maximum. That means sine 2 theta has to be 1. That means 2 theta has to be 90 degrees, because sine 90 is 1, and therefore theta is 45 degrees. That means for the same velocity, if I keep u same, when I throw this object at an angle of 45 degree, I'll get the maximum range. Therefore, this R max is when theta is equal to 45 degree. So that means this is u square sine 2 theta by g, and its maximum value, so sine 2 theta is 1. So the maximum value is u square by g. That would be the maximum horizontal range. Now, what would be the maximum height? We know that h is equal to u square sine square theta by 2g. Now theta is 45 degree, so I'll get u square sine square 45 degree by 2g. So this will give me what? U square sine 45 is 1 by root 2, and square will be 1 upon 2, so I'll get 2g into 2. So u square by 4g. So this is the value of h, u square by 4g h. And what is the value of r? R is u square by g. So if r is u square by g and h is u square by 4g, obviously r max is equal to 4 times that of h. This is how we can prove this. Okay, so this is question 8 that we have done, and let's call it a day. I thank all of you who joined in. Any last comments? Anything you want me to do or talk about? Okay, so with this we'll wind up this, and what I'm going to do is I'm going to simply save this last file as question 8. Yes, Bhavya Gupta has joined in. Uh, Bhavya, are you a student? I don't. Uh, Probably, I still don't know all of you by your names. Are you a student of 11B, Bhavya? Bhavya, can you identify yourself? Dhruv, you're saying no, no for what? Okay, he is not in 11B. Is he in one of our other sections, 11A or C? Even if he's not a part of our school system, that's perfectly fine. If somebody else joins in, we don't have any issues with that. Bobby, welcome. Can I ask a doubt, sir? Sure, Bobby. First, can you identify yourself? You are in which school, which section? Bobby, you can certainly ask a doubt, not a problem. But yes. Okay, no, not a problem. If Bobby will introduce himself. He has joined us. Uh, okay, Montfort School, which city? Uh, I said which city. I understand you would be a class 11 student since you have joined this, and you're welcome to this session. No, absolutely no issues with that. Which city are you from? And of course, you can ask me your doubt, not a problem. Uh, Poojan, let Bhavya respond to that. You don't respond to that. Let him identify cities. Or do you know him, Pujan? Since you are writing Delhi for him, do you know Bhavya? Okay, Bhavya. Right. As I said, welcome. And if you have any questions, ask me. If possible, I'll respond right away, or maybe then we will. I'll respond to you via email or something. Yeah. Go ahead. Mano, don't push him. Let him take his time. Okay. So that's how we were. Bhavya, what you can do is, can you send me your email ID separately? I'll respond to your question. Not here. Maybe you don't want to share your email ID over here, but you can, I'm assuming that you have subscribed to my channel. Is that right? So, mm, what I suggest is then I'm just mailing my, just writing my email ID over here. Uh, you can write to me on that email ID and I'll respond over that. This is my email ID. Just you can send your queries on this question anytime and as many questions as you want. Uh, that's perfectly fine. Or you can put it as a comment on my channel. I'll respond to that and I'll respond quickly. Okay? And you can ask me any number of questions. Absolutely no issues with that. Is that okay with you? Uh, Great. All right. And I'll certainly love answering your questions. Okay, everybody. Good night, and
जेव्हा ती पाठीने दिली तर मग त्यांना सांगून द्या या डब्यातली राहू दे, जसं सकाळसाठी ठेवली दिली त्यांनी तर कोणती एक राहू द्या. तुम्ही आता झोपत का नाही आता अजूनही तुम्हाला बरं नाही काय
ओपन है एसी जरूर पण नहीं है ऐसा.
एसी पंखाच ठेवतो आता